Okay, so let's start off today with the power rule. So, power rule. So the derivative with respect to x of x to the n power is going to equal n, now x to the n minus 1. Okay. So let's say we were taking something like the derivative with respect to x of x cubed. What is that going to do? That's going to spit out a 3, and it's going to drop the exponent down to 2. So let's say I was taking the derivative of x to the 4th. Well, it's going to spit out a 4, and it's going to drop it down to a 3. A couple ones that they follow the rule, but if you think about what is the derivative of x, of just x, you can think of this as like x to the 1 power, then multiplied by x to the 0 power. So the derivative of x, the derivative of something that's linear, would just become a constant. And if you take the derivative of something that is constant, let's say 5, well, that's going to come out to being 0. Okay. But when you do this problem, you see I'm using whole numbers here, so x cubed, x to the 4th, stuff like that. It does not have to be integers in the exponent at all. Okay? So let's say I wanted to take the derivative with respect to x of something like the square root of x. Okay? If you want to think of this in another way, what is this really? You can think of it like this. This is really x to the 1/2. Okay? So what is that going to do? That's going to spit out a 1/2. And if we say 1/2 minus 1, that's going to be negative 1/2. Well, let's say we were going to take the derivative of the cubed root of x. Well, that's the same thing as saying the derivative with respect to x of x to the 1/3 power. So that's going to become 1/3. Now, x, we have to think, well, what's 1/3 minus 1? So that'd be 1 over 3 minus 3 over 3. So 1 over 3 minus 3 over 3 would be negative 2 over 3. We can do this with other fractions as well. So let's say we're going to take the derivative with respect to x of, let's say, x, say 4/3 power. Okay. So what is this going to do? This is going to spit a 4/3 out to the front. So that's going to be 4 divided by 3. Okay. Then we have to think, what's 4 divided by 3 minus 1? So what would that be? That would be 4 over 3 minus 3 divided by 3. So 4 over 3 minus 3 divided by 3 would be 1 divided by 3. Okay, so you can do this with fractions. There's no issue with it. Okay? We can even do this with negative exponents. Okay? So if I was going to take the derivative with respect to x of 1 divided by x. Remember, another way to write this problem would be the derivative with respect to x of x to the negative 1. So we have something to the negative 1 power, so that would be negative 1 times x to negative 1 minus 1 would be negative 2. Sometimes people would like to write it like this. Negative 1 divided by x squared. Right. So let's say we took the derivative with respect to x of 1 divided by x squared. Okay, so another way to think about this is x to the negative 2 power. So that's going to spit out a negative 2, and then we'll multiply by negative 3. Sometimes you'd like to write it like this. Let's see what happens if I continue this process. So, okay, so the derivative of 1 divided by x squared is going to be negative 2 divided by x cubed. So let's say I'm going to take the derivative with respect to x of negative 2 divided by x cubed. All right, now I'm taking derivatives. Ignore the constants. You're taking a derivative with respect to x, so you're taking a derivative of just the x variable. So what is this? We're going to take the derivative of x to the negative 3. So it's going to spit out a negative 3. Well, the negative 2 and the negative 3 will cancel each other out. So we're going to get 2 times 3 divided by x to the 4th. Let's see what happens if I continue this process. Let's say 2 times 3 divided by x to the 4th. Okay. So we're ignoring the 2 and the 3, and we're taking the derivative of, what is this, x to the negative 4. So what is it going to do? It's going to spit out a negative 4, and it's going to drop it down to negative 5. So since it's spitting out negative 4, this would be negative 2 times 3 times 4 divided by x to the 5th. Let's say if I did this again. Say negative 2 times 3 times 4 divided by x to the 5th. Okay. Now this guy is going to spit out a negative 5, and it's going to drop it down to negative 6. So if I spit out a negative 5 into this situation, the negative 5 is going to cancel out that negative sign, so that's going to be 2 times 3 times 4 times 5 divided by x to the 6th. And let's do this again. Say I took the derivative of 2 times 3 times 4 times 5 divided by x to the 6th. That would be negative 2 times 3 times 4 times 5 times 6 divided by x to the 7th. Okay, so doing this process of derivatives or integrals, we're going to get to the integrals later. It actually leads to this this formula that you might not have seen in the past before, but it's it leads to factorials. So in factorial, be 1 times 2 times 3 times 4 times 5 dot dot dot. I'll write it like this. N minus 1 all the way up until n. Okay. Factorials become very important in mathematics. They appear a lot in probability. So if you're asking, I'm trying to make a choice between different objects, you'll end up with n choose k, which is, I don't know the formula off the top of my head. I think it's n factorial divided by k factorial also divided by n minus k factorial, if I'm remembering correctly. Factorials are also going to appear a lot in Calculus 2. So whenever you get into Calculus 2 and we start talking about Maclaurin series or Taylor series, infinite series, they have a lot of factorials from them. And it has to do with this process of repeatedly integrating or differentiating some type of polynomial. So this process leads to a lot of very rich mathematics. Okay. Well, do they have to be integers on bottom? No. Let's say I wanted to take the derivative with respect to x of 1 divided by the square root of x. Okay. Now another way to write this would be x to the negative 1 divided by 2. Okay. So that's going to spit out a negative 1 divided by 2 and then multiplied by x. Right, so negative 1 divided by 2 minus 1 would be negative 3 divided by 2. Okay? So you can do this, just remember whenever you're doing something involving a fraction, just make the exponent negative and try to think about the problem in that way. And so you can do a lot with this. So there's another very important property that actually goes along with derivatives. That would be linearity. Okay. So what do I mean by linearity? Okay. So let's say I was going to take the derivative with respect to x of, doesn't really matter what I pick, x to the 7 plus, let's say 6, x to the 5th, plus, say 4x cubed, plus 12. Now what I mean by linearity is that if you have things added or subtracted together, you can do those derivatives each individually. If things are multiplied together, you can, or divided by. I mean, if it's a fraction with a function on top and bottom, we'll get into that in the next video when we talk about the product and the quotient rule. So, if I was going to take the derivative of this guy right here, what am I going to do? I'm just going to take the derivative of each component individually. So, this thing would equal, now 7x to the 6th. Okay, so this is going to spit out a 5. So 5 times 6 is 30. X to the 4th. Now this is going to spit out a 3. And so that's going to be plus 12 x squared. And then, well, the derivative of 12 is just 0. It's a little redundant to write that 0, but I'm just trying to make a point. Okay, so that's the power rule. Now let's go over the trigonometric ones as well during this video. So this is actually going to be more of a list of just the common trigonometric functions. And once we have the derivatives of our different functions, we can start applying the product rule and the quotient rule. So, first thing you need to know is that the derivative with respect to x of sine of x actually equals cosine of x. Now let's examine this as comparing these two graphs. Okay. Now sine of 0 is 0. Okay. Up, down, up. This region right here as well. So this is sine. Now if we consider its derivative, which is cosine, so cosine of 0 is 1. This. That. Okay. Now think about what's going on in this picture right here. So if I, all right, so remember when we're talking about the derivative, you're talking about the slope tangent line of these two curves. I mean, of this curve, okay? So if I consider this line right here, what's its slope? 1. Okay? Now, if I consider this tangent line right here, what is its slope? 0. Okay? Now, if I consider this tangent line right here, that would have negative slope. That would be down here at negative 1. So, let's go through the other ones. Okay, so we have the derivative of sine. We have to consider, well, what would the derivative of cosine be? Would be negative sine. Okay, so we have the derivative of sine and cosine. Now let's consider, the other ones you really need to consider is secant, tangent, cotangent, and cosecant. Now, whenever remembering the rules for secant, tangent, cotangent, cosecant, all that stuff, the main thing you want to remember is that if you know the rules for secant and tangent, they're derivatives. You know the derivatives of cotangent and cosecant. Just remember they always get a minus sign. And remember, secant and tangent are always going to be associated with each other, and cotangent and cosecant are always going to be associated with each other. So, the derivative of tangent of x is going to equal secant squared of x, and the derivative of secant of x is going to equal secant x tangent x. All right. So these are the two rules you need to know when dealing with derivatives of all of these functions. So what I mean by the rules are the same, a little bit. If I took the derivative with respect to x of cotangent of x, that's going to be negative cosecant squared of x. Okay. And if I took the derivative of cosecant of x, that would equal negative cosecant of x cotangent of x. Okay. So those are really the trig derivatives that you need to know.